Hello everyone. Can anyone please confirm the audio screen share before we get started? Anyone please? Okay, thank you. So please give me 1 minute. 1 minute. Let me fix something. Then we'll get started. Okay, I think we should be okay now. Bismillah. Good morning, good afternoon, good evening. Assalamu alaikum wa rahmatullah. It depends on from where you are joining the program. Welcome to Big Bang Data Science Solution, week number 4, and today we are going to continue learning some of the steps needed for NLP, for pre-processing and post and pre-processing. So it's a continuation of what we learned last week. The week today we are going to learn simply we are going to talk about this flow or this pipeline. So we are going to learn how to tokenize the data, remove some stop words, and we are going to learn stemming and normalization. Few things, and we should be done very quick today. But this is what we plan to learn. Next week, then we are going to move into pre-processing, then extracting some feature extraction, and then making decision. The files they are already the files already been shared with you guys on the canvas. Yeah, the files are already on canvas in week number 4. So for those who have not accepted the invite yet, please go ahead and do so. We sent you an email a couple of days ago. For those who have access to the canvas, so please go to week number go to week number 4 and just simply click on the training materials. You should be able to get into the file that we'll be using. So Jupyter notebook that we'll be using, it's under codes. Yeah, sorry guys, I think yeah, let me do one thing. Yeah, I need to delete all these folders because this is from week number 3, and I will upload the file shortly. Just give me 1 more minute, then we should be starting. Okay, so the file is there. Go ahead and download it, and if you want to follow up with me, that's fine. If you want to simply watch me listen and do it later, that's totally up to you. Okay. Again, I mean, this is a preloaded file. It's already the code's already been there, but I will try to explain the codes as much as I can. As I said, in today's session, we are going to complete the process of pre-processing. Simply, we are going to learn tokenization, how to tokenize a sentence to a words to a tokens, or a paragraph into a sentence. Then we are going to learn how to remove stop words, or the most frequent words, or the common words that wouldn't add any value whatsoever to the analysis. Then we are going to stem. Lematize and stem is simply trying to determine the root or the stem of the word and remove the affixes. Then, of course, sometimes we have we might need to normalize. Like if you have a word, if you have US, you could normalize it, transform it into United States of America. UK translate it, transform it into United Kingdom. Or just for normalization. Yeah, that is what normalization is all about, is finding the actual meaning of a word rather than using an abbreviation. This is a type of normalization. So after we have ready to go data, then of course next step is to pre-process it, then transform it, or transform it into a matrix, into sparsity matrix where we have zeros and ones, and finally use it for with machine learning. Okay, so yeah, we are going to learn. Today we are going to learn tokenization. Then we are going to learn post tagging, part of speech. Then we are going to learn stop word removal. Then, of course, we are going to learn normalization. Then we are going to learn spelling correction. Then we are going to learn stemming. Then lemmatization, and finally named entity recognition. Of course, word sentence disambiguation. So a few things. A few things that we are going to learn today. I don't think this is too clear to you guys, so let me zoom in a little bit, and in the chat please tell me if it's clear. Yeah, in the chat please tell me this is clear so we can proceed. Okay, so the first thing we got to do here is we are going to grab a sentence from Yahoo. Yeah, go to yahoo.com and simply grab a sentence, or grab a paragraph. So let's grab this paragraph here. Very simple. And so we are going to create a variable. We are going to create, number one, we are going to import the NLTK, which we already been imported. And then we are going to create a variable called sentence. You can call it whatever you want, and we pass to it a paragraph, a sentence, whatever you want. And we create the variable. Here we go. So we have the variable called sentence, and in the sentence, this is what we have in it. Washington, US President Joe Biden, blah, 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 all the way to the end. And we want to simply play around this paragraph to see if we can get into something. Here we go. I think it should now it should be clear. Okay, so we are going to create. This is one way to do it, but of course there are many ways to do it. So we are going to create some of the functions, predefined functions. And the first function that we are going to create is find a word. So this function takes two parameters. So it takes two parameters, a word and a sentence. So this is simply X and Y, or you could name it whatever you want. So it takes two things, two parameters, X and Y, word and sentence, and is going to return the sentence itself. And what we are trying to do with this sentence, we are trying to find a word in it. So we're trying to find the word nation in this paragraph. So let's name this paragraph para for short. Okay. Simply because I'm using a sentence, a paragraph. So do we have a nation in this paragraph? Or if you're looking for a word, you could use whatever word, but we'll try the nation first. And yes, it's there. I believe it's there. Or let's look for Africa. Do we have Africa in this paragraph? It's there. Do we have, let's say, Morocco? This is my country. It's false. I mean, there is no Morocco in this paragraph. So play around it and see if other words, just play around it to see if you can, just play around these find words. One thing's, this is a function. This is a predefined function. Simply looking into this paragraph for a certain word and return that word in that paragraph. And one thing that to be aware of. So if you have, let's say you have many paragraphs, and you have apostrophes, you have quotation marks, single or double. When you create, when you create that parameter or that object, simply you might need to put triple quotation, especially if you have single or double or apostrophes within your paragraphs. So you need to change this, make it three quotation marks. Otherwise, it's not going to work. It's going to yell at you. And also, since we have a paragraph, so let's say that we want to find how many words that we have. We want to find how many words that we have. We want to find index, the location of the word president, for example. We could do that by simply. We are going to create another. We are going to create another function, get index, and this get index. It takes two things. It takes the word. It takes two parameters. Whatever. In our case, we named them a word and sentence and text. And it simply return the index of the word. So for example, and you have to have a word like for example, let's say we want to find the index or the location of word Biden. And by the way it works is you create a function. It's simply a function. If you run it, if you run it, it runs. But we don't know if it's going to work until we actually demonstrate or have an example. So we created a function called getIndex, and we pass it two parameters, word, in our case it's word and text. And so it takes two parameters and it returns the index of the first parameter. So now we are trying to apply this getIndex function on the word Biden and in the paragraph. Let's create, because I don't want to keep changing this. Okay, now let's get Biden, and it's 41. So if you count, it should be. This is what I mean. This is go by characters, by the way. If you count, then you are gonna find it's in the location 41. And also let's get another one. For example, Morocco. Now get index of Morocco, and we don't have any Morocco in the this paragraph. Of course, you are gonna get an error. Morocco is not in the list. Morocco is not in the list. If we pick another word, like for example, Africa or South Africa, it should be in the last one. How about Africa? Africa is not on the list. Why is that? No, I know this is Africa. Okay, let's run this again. Try to find Africa first. Africa is there. Yeah, for a reason it says Africa is not on the list, but Africa is there, and I don't want to troubleshoot this. How about South? Yeah. And now if it's case sensitive. And no, for a reason it's not okay. Yeah, I think it's CLN on the it's CLN on this split. Yeah, we got the 280. And how about if you want to find if you to want the rank or the index is per character. How about if you want to find a rank of a word, for example, property. So we are going to create another function. Predefined function is get word, and of course we are going to take we create the function. Yeah, we create the function, and it takes two parameters, text and rank, or give this simply parameter. This is names, and it is gonna return a split. Yeah, split is gonna split the text. I split the first parameters, and is gonna return the rank or the position of that text within. Looking for the rank of that word within the text. Like for example, if you want to find rank number 2 or word number 2 or position number 2, it should return this word. Okay, so let's run this. Create the function first, and now we are going to look into the sentence, and we're looking for position number 2 or rank number 2. And yes, let's say that we want to find so this is 0, this is 1, and this is 2. So in the indexing with in Python starts with 0, in R it starts with 1. So let's say that we want to find nation. So we got this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if you do the 10, we are going to get, we should get, if my math is correct, we should get the nations. So this is a very simple, searching the paragraphs, a very simple way of searching the paragraph. Of course, there are other ways to do it better, more efficient. But we are trying to start with how we with playing around a text. It's called text analysis. Trying to work around the a text or a paragraph in general. So what if you want to print, if you want to start from the end, this is indexing. So if you want to display the first index, is we start with 0. If you want to display the last index or the last word, it's -1. So this is -1, this is -2, this is -3, and this word is -4, -5, all the way to the end. So so to print the third word, the last word, to play the last word, to invert a word. So for example, number 10 that we already know is a nation, but we want to invert it. It's going to be S first, and you see S Norton. Nation now becomes, it's read now from right to left. Okay, and how about if you want to say take only 2 words? Now take only 2 words of this paragraph. Let's take, for example, president and identification, for example, and we want to eliminate everything and concatenate them. So we should get president's identification. So to do that, we are going to create another function, and this function, it has only one parameter. So yes, we are going to take that one parameter. We are going to split that one parameter into words. It's going to split into a token into words. Then we are going to take a word. Yeah, we are going to identify the word that we are going to take. It should be the first word by simply identifying its index. So if you want to take, for example, the word Washington, is going to be 0, 1, and 2, and 3, all the way to the end. So we are going to specify the first word by simply identifying its index. And the last word is going to be the length. So the length of the word. So let's say that we have here 100 words, and we want the nation, the identification. So the first word is going to be 3. So you got 0, 1, 2, 3. And the last word is going to be 100 minus 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's going to be -9. So if you do -9 and 3, we are going to get the word president, assuming that my math is correct, and identification, and assuming that we have 100 words. Let me see how many words that we have. Length of the para. So we got 287. So if we were to get, let's have a correct name or a correct map. Okay, so this is our paragraph, and we got 247. No, we got 287 words, and now we want to concatenate 2 words in our president. So we are going. This is 0, 1, 2, and 3. So we are going to take the number 3. So this is the first word, and identification, the second word. So it is going to be minus 1, -2, -3, -4, 5, 6, 7, 8, and -9. So it's going to be here -9 if you were to get to this word. So what is this this paragraph does? It simply so we need to identify the first word, and we need to identify the second word, which is the length of or the number, the length of the paragraph minus whatever value that you are looking for. Okay, so in our case, so we are going to do here, for our example, we are going to do 3. We are going to do 3. So the first word is 3, and the second word is -9. So I'm expecting to have as an output president and identification. And of course, we concatenate them. Okay, so this is the paragraph we are going to use, the function we are going to use. And now we are going to concatenate. It's a run it. It is going to work regardless. But I mean, the codes are, the function runs, but we don't know if it's going to work. And now we are going to pass into it the sentence. What is in the sentence or the para? So we are going to pass into it the entire paragraph, and it is going to look for index number 3, which is president. And for the first word, so the first word is going to be president, plus the second word or the last word is going to be in our identification. Here we go, president. Yeah, I'm sorry, president identification. Okay, so let's say that we want to print the even positions. So this is all index. So if you want to print Washington, USA, Joe Biden on call, so we are going to print the even positions. Of course, there is going to be a little math. So we are going to create another function. It's called get even position. Name it get even position words. And what it does, we are going to split this sentence. Splitting is a very, very critical. This is how we loop through words by word, word by word by simply tokenize them or splitting them into words. So this is all words, and we are going to go through every single word index and do the math. Simply multiply it by 2. So if the remainder is equal 0, then that simply means this is an even, and we want to print all those words that they have an even position within the sentence. So there we go. So we start with so US. This is index number 2, index number 4, index number 6, index number 8, 10, 12, 14, 16, 18, 20, etc. So if you want to do the odd, simply we are going to do here greater than 0. Good work. There we go. So we got this is I believe this is 1. And this is 1, and president is going to be 2. So you got Reuters and President Biden Friday. So this is a very simple, looping through or doing some basic, very basic text analysis, trying to find the index of a word, trying to find the rank of a word, trying to split the paragraph into words, and also creating functions to do few things for us. Very basic, as you see, very, very basic text analysis. And this is the starting of NLP. NLP is all about analyzing the text. Of course, you could analyze speech, but the focus of this 3N program is all about the text analysis. So you get the text. So of course we need to understand it by simply applying some of the pre-processing NLP processes, and few of them is simply looping through your paragraphs, your sentences, and understand the content, understand the position, understand the indexing, and playing around it. That's very simple things that we started with. So of course, when you have a sentence, when we have a sentence like this, this is a paragraph, for example. This is a big paragraph, and if you want to understand, if you want to apply some, if you want to make it ready for analysis, not every single words that we have in this paragraph is needed for the analysis. So we need a method of looping through the content and to determine if the word or the string or the sentence is needed for the analysis. So one way to do that, if we want to loop through every single word of the paragraph or the sentence, we need to tokenize it. It's called tokenization. Tokenization is simply a split. Is a split into single words. So you have a paragraph like this, and we want to simply split it into words using the tokenization method. That is very simple, and we are going to still use the same paragraph. We are going to still use the same paragraph that is we used earlier. There we go. So we are still going to use this paragraph here. And as I said, we are going to need to split this paragraph into single words. And what I mean by tokenization, it does take into account the white space. It does take into account the punctuations, the numbers, the strings. So it is going to split. It's going to treat every single thing within a sentence as an entity. And that is how important tokenization is. It is going to help us to later navigate or loop through every single word, every single token. We are going to go loop through every single token and determine if it's needed. So we are going to compare the token to a stop words. We are going to compare it to punctuations. We are going to compare it to a words, to numbers, and remove them accordingly. So we are gonna let's for a few things that we gotta do is, number one, we are gonna import from NLTK, because we don't need to import everything. We are gonna import as we need. NLTK is a huge library. It has a lot of methods, a lot of functions, a lot of good things that you could utilize to pre-process a text. So we are going to import the word tokenize, and of course we are going to import a few things. Stop words, one of them, and average percentage tagger if you want to do some math. There we go. It's done. Of course you are going to get this. It's not an error. It's simply it's simply some logs. And sometimes if you run it twice, it will disappear, but for a reason it's not. And you might need to put the warning to avoid. You might need to import, put warning, avoid warning, or avoid this type of logs if you need to. Okay, so we are going to use this NLTK. It comes with a word tokenize as a method, and of course it comes with the sentence tokenize if you want to tokenize the entire paragraph into sentences, which is not our interest today, but we want to split this paragraph into tokens, into words. So we are going to create a function and that function, it takes one parameter, which is in our case the paragraph, and it splits, it applies the word tokenize, which is a method that we just imported from the NLTK. So it applies the word tokenize to that sentence, and it returns it returns a split. So the words is simply the sentence being tokenized, a sentence or the paragraph being split into words, into small units of data. So we are going to create the function, and we name the function get tokens. Run it. So we have the function, and now we are going to take this function and we are going to apply it to our paragraph. Let's do that. And here we go. So now it splits the entire paragraph into it splits the entire paragraph into tokens or into words. So this is the paragraph, and if you look into the output, we got Washington, it's a word. So we got one word here, the first word, and as I say, it takes the punctuation or special character. So special character, the opening parent is an entity, Reuters again, then the closing, then US and president, etc. So with this list of words, then we can definitely navigate through them by using a looping function, to loop through the content of this tokenization outcome, and compare them to either, in our case, we are going to compare them to stop words, we are going to compare them to numbers if we want to, we are going to compare them to functions, to punctuations, and remove words that meet the criteria accordingly. Okay, so let's create another one. So we got a sentence here. It's I am reading NLP fundamentals, or I'm learning NLP. I am learning NLP with BBDS for free. Okay, so it is simple. We are going to apply get tokens function, and we already know what this get token does. It simply is going to take an input. It takes one parameter as an input, and it returns another parameter, which is simply a tokenized input. So input will be tokenized. We are going to apply word tokenized to that input. So I have a sentence. So we are feeding. This is the parameter that we are feeding into this function, and I should get I am learning NLP with BBDS for free as the output. So I am learning NLP, and even you see the punctuation is being considered. And if we do the space, normally this is called white space, but it's not considered. Okay, that is tokenization, and this with tokenization we can do anything we want. We could do post tagging, pause tagging. We could we are going to use it to remove stop words, and of course we are going to use it for other things like text normalization and spell correction, etc. So we have to transform the paragraph or the sentence into a single words, so we can to make it easy for us to navigate through the words one by one, and of course it's very the process is very fast. and compare these words. They are called token to the list of items that we have, and take an action accordingly. Another method, which is a great method that we need to learn about this NLP when dealing with text, is simply trying to find the post tagging, the tag of a word. So it is this post tagging. It really helps to understand the actual meaning of a word. If we understand the tag of a word, of course, we might determine the actual meaning of the word. So this NLTK, the function, the library NLTK, it comes, as I said, with many methods and functions that you could utilize to play around your text. And one of them is post tagging. So to print out a list of tags, there are many tags that deals with words, special characters. So if you see the sign, simply you are going to see another tag is going to be a currency. Single quotation or double quotation is closing quotation marks. If it finds a parenthesis, it's going to tell you this is opening parent or closing parenthesis, a comma, etc. CC means conjunction, coordinating. CD, numerical, cardinal. DT, determiner. Foreign word. So if there's a word that it does not understand, if you are using English and you have a word in French or a word that does not understand, of course you are going to get FW. So let's go through the paragraph that we have, this paragraph, and see if we can determine the tagging of every single word. To do that, as I said, we are going to import from we are going to use the post tag underscore tag method, which comes with the NLTK library, which we already imported from the beginning. Okay, so again, we are going to import word tokenize, which already did, and we are going to import the post tagging. Why do we need a word tokenize? So first of all, we need to tokenize the sentence. We need to split the sentence into single words, and we are going to compare so we can navigate through each word one word at a time. So let's import the methods first. So we are going to import a word tokenize, and we are going to import the post tag method from the library NLTK. So we are going to create a function. Again, this is to tokenize our sentence or our paragraphs, and it's simply copy paste of the previous snippet of codes. So we are going to create a function. Actually, we don't need to create it twice. We already so we don't need to do this. But let me explain what we are doing again. So we create a function called get tokens. It takes one parameter, one input, and it tokenizes that input, and it displays or returns an output, which is simply a tokenized input. So it takes an input, tokenize it by simply applying the word underscore tokenize method, which is a method that comes with NLTK library. And what it does is splits into single words and single entities. Okay, and now we are going to apply that in a paragraph. Okay, so we are going to tokenize the paragraph. Here we go. So we are tokenizing our paragraph, Washington, blah blah blah, all the way to the end. As you see, it does recognize the special characters. It does recognize the numbers. It does recognize the punctuations, and does recognize the string. Okay, so now we are going to apply the post tag for every single word, trying to help us understand the tag of the words. The more you understand the tag of the word, the more you understand the true meaning of a word. Now, there is one way to avoid the ambiguity within the text. So we are going to create a function. It's called getPause, and it takes one input and applies the post tag, which is a method. So this is a method. This is a method that comes with the library. It's a method that comes with the NLTK library. Okay, so we create the function, and it takes one parameter, and we take that one parameter and we apply the post tag method, and we return the and we return the tags for the input. So the words here, or the input, it is going to be our paragraph. So it is going to take this paragraph, which already been tokened, already been split into tokens, and is going to go through every token and apply the post tag. Okay, run the function, apply the function, and here we go. So Washington is NNP, and what is NNP? Noun, pronoun singular. Okay, the second one is this is of course this is a parenthesis, and we already have that in the list. Closing parenthesis, opening parenthesis. And Reuters is NNP, again the closing paren. USA is NNP, on, IN, NNP, verb, past, etc. So we got a lot of tags that we can use, and these tags help us, as I said, understand the true meaning of a word. LS means list of items, MD model, NN, double N is known, common singular. NNP, NNPS is a plural. NNS is a plural again. PDT is predetermined, determiner or determiner. Pause, genitive markers. So RB, adverb, RBR, comparative or adverb. RBS, superlative. Of course, symbols. If you have some special characters in there, you are gonna get this SYM. VB, verb. VBD is a past tense. VBDG is present. VBN is past participant. VBP is past tense again. VBZ is present tense, third person singular. And so we got a lot, but this is the most common tags that you can use to help you understand the true meaning of a word. So we got all our words being tagged. As I said, the first process is number one. You need to tokenize. We need to tokenize the paragraph or the sentence, or splitting the paragraph and the sentence into words, and we are going to use that list of tokens to do our process. Second things that we want to be able to use today is remove stop words. A stop word is the most frequent occurring words in any language, and as we saw last week, there are only few languages that can be supported. Yeah, let me pull up that file one more time, please. It's going to be week number 3. Yeah, this is the file that we used last week, and I believe we went through this. Let's go through this one more time. And few of the languages are actually being supported. Yeah, where is the codes for that? Yeah, so these are the languages. Let me copy this. So these are few of languages that have been supported. So it depends. Okay, let's import the. We are going to import the stopwords first. Here we go. So these are the list of languages that have been supported. They have their own stopwords. Arabic is the first. Arabic, of course, one of them. I know it does not support all the 6,000 plus. I believe 6,000 plus languages. But these are the list of the common ones, more supported. So from the NLTK we are going to import the stopwords, and of course we want the English one. We want the English stopwords. I believe it should be where is English? Yes, we need the English stopwords. So we need to stopwords for English. Okay, so what I just did here is I simply downloaded the stopwords from NLTK, or imported from NLTK the stopwords, and all I'm interested in is the English stopwords. I don't care about other languages at this point of time. Let's take a look into stopwords, and as we saw, or we learned from last week, the English stopwords, they are modern English, as you might see. Of course, if you are working in ancient paragraph that use old English, it's not supported. So you might need to update. You might need to modify the list by simply adding the words that you think should be added. Okay, so we imported the list of stopwords. We imported stopwords, and we imported only English stopwords. And now what we have to do again, we are going to go through the paragraph. In our case, we are going to go through the words. We are going to go through the words, and we are going to remove all the stopwords. So in stopwords, we are going to remove punctuations, special what do you call it, special characters, and of course we are gonna remove the most common words like on, the, at, to, on, to, of, and, a, of, for. So if you were to display or to find the most common words within a paragraph, of course the stopwords will come first because they are being used more frequent than compared to other words. And we are not interested in these words. They wouldn't add, as you see, they wouldn't add any value whatsoever to the understanding of the paragraph. So that's why we need to remove them. Okay, so to do that, the first thing we gotta do here is we need to tokenize the paragraph. We need to split the paragraph into single words. And what it does, the process is going to compare each token of the paragraph. It's going to compare Washington, for example, to the list of the stop words. If Washington is in that list, remove it, otherwise keep it. And it's going to compare the parent, this function, the special character to the list. If there is a special character similar to it, just remove it, otherwise keep it. And it's going to compare all the words that we have, all the tokens that we have in this paragraph to the list of stop words, and keep if don't exist, if none are similar, and remove them if they are similar. So that is what we are trying to do here. So we are going to compare the tokens that we already established with this list and remove or keep accordingly. Okay, so again, I'm going to use sorry. So I'm going to use the paragraph again. So we're creating a variable. It's called sentence words, and the sentence word is simply the paragraph that we already have from the beginning and tokenized. Let's take a look. Now we are going to print. So it's tokenized paragraph. And now what we're going to do here is we are going to loop through. We are going to use the for loop. We are going to look for every single word in the sentence, and we are going to compare it after with the words in the stop words. So we are going to compare the tokens of this paragraph with the list of items that we have in the stop words. So Washington, it's not in the list, we are going to keep. Print, we are going to keep because it's not in the list. Reuters, we are going to keep. On, it's in the list, and you should see it somewhere here. So we got on, and we are going to remove. Okay, so let's do that. So we are going to build a function. We are going to build a function. And now let's now we are going to build a function, and now we are going to run it. Now we are going to apply it. Okay, so we build a function and remove stop words, which takes two parameters. It takes the two inputs. It takes your paragraph or your sentence and the stop words, and it's going to loop through it's going to compare the tokens of the first input with the items and the second input, and keep them if they are similar. Remove them if they are similar, and keep them otherwise, and also concatenate them later. Let's take a look. Here we go. So it compares Washington to the stop words. Of course, we don't have Washington in that list. Okay, so this is what it does. Okay, so it takes the first sentence, the first input, which is the paragraph. It takes every single token of the paragraph, and the first word is Washington. Compare it to the stop words. If we look into the stop words, you are not going to see Washington, so we are going to keep it. Then the second index, or the second token of the paragraph, is the opening parent. There is no opening parent, we are going to keep it. Other than that, everything is going to be, everything is will be kept. So sometimes, you are not going to get a cleaned text. Of course, you might need to modify or update the list of stop words. So we really need to remove this punctuation. Yeah, we need to remove that. So mail word, trade organizer, everything else is in, it's simply most less frequent words. So the most frequent words are already removed, or the most common frequent words are already being removed. So let's remove this. So we could do that by simply updating. We are going to update we are going to update the list. We are going to extend. We are going to add. We are going to, to the stop words, to this list of stop words, we are going to add the opening parenthesis and the closing parenthesis and the comma. Okay, and let's take a look into stop words first. So we are going to update, and let's take a look. Here we go. If you look into the stop words, we are going to see at the bottom, we are going to see the opening parent, the closing parent, and the comma is being added. And now we are gonna start the process. We are gonna apply the remove stop words function, and we are gonna apply this function. We takes two parameters again. It takes two inputs. It takes our sentence or our paragraph. A paragraph, and compare it to the stop words, and keep the words if they are not, keep the tokens if they are not in the paragraph, or remove accordingly. Now we got so before we got the closing and opening parent and closing parent, they are gone, and the comma is gone. So now we have a pretty clean text that we could analyze. Otherwise, if you have many paragraphs you're trying to analyze, and if you don't remove the stop words, of course, for the frequency, you are gonna see these common words are more frequent. Okay, so another things that we could use for our text is normalization. Simply is changing the sometimes you might need you have some abbreviation, and which you might know, someone else might not know. So instead of using misspelled words or abbreviation, we could normalize them. So what we could do here, and this is a manual function, so we are going to use the replace function. We are going to use the replace function to replace a word, an abbreviation, by its actual word. So we are going to create a function called normalize. It's simply a function. You could name it whatever you want. This is a predefined user defined function. You could name it whatever you want. And this function, what it does, it takes one parameter as an input. It takes one parameter as an input, and in our case, we know what in our case it's going to take some of the abbreviation that we already know. Like for example, I visited the US from UK on the 22nd of October 2018. So we want to change the US to United States and UK to United Kingdom, and of course we want to change the 18 to 2018. So we are gonna use the replace function. This is a function. The replace is a pandas function. It's a function. Probably if we have a chance to learn pandas later, we could use it. And what it does, this replace, it replaces something with something. So it replaces US with United States, replaces UK with United Kingdom, replaces, and you keep continuing. You want to replace, for example, let's say I with let's say we. Okay, so now let's run it. This is simply a function. It works. The function, there is no syntax error, but does it work? We don't know yet. So we are gonna apply this normalize to to this sentence. So let's first create a sentence, and we are gonna normalize it. So in the sentence, so let's compare this. Yeah, we are gonna do here print sentence and print the normalized sentence. And now there is a misspell. Yeah, come on. Here we go. So this is the original sentence. I visited the US from UK on this blah blah, and now we visited the United States from United Kingdom on this date. So using the replace function to simply replace abbreviated words or some of the errors that you have in the text. Okay, and now NLTK has a method to correct the spelling. It's called the speller. Actually, it's not an LTK method. It's an autocorrect method. Autocorrect is a library. If you want to navigate it. I believe it's a library. Here we go. Yeah, it's not. Yeah, version 2.6. So we are going to import this library, and so simply you need to install it first. Pip install autocorrect. Otherwise, it's not going to work. So pip install. Simply run this. You need to uncomment this line and run it. I'm gonna do it, but I already made the requirement. I already did last night. There we go. So requirement already satisfied, and from this autocorrect, I am gonna import this speller. And again, to check spelling of a word, we need to tokenize. We need tokenization is an important process. So we need to split our paragraphs, our sentences into words, and we are going to compare those words with an online dictionary. I think that is what it does. So autocorrect is simply comparing the words with an online dictionaries and fix accordingly. So we are going to import the word tokenizer again. Then we are going to import the speller from autocorrect. Okay, so and you need to specify now this speller. It does support I believe many languages, and one of them is English. So we need to identify the language that you want to correct. You want to apply the correction. Okay, so we got a word here. It's called natural, and we want to correct this, of course, using English. So what it does, the speller, it takes this word and compare it to words that we have in the this online dictionary, and simply trying to find the closest word to it, and which is natural. Okay, let's do this. And we got natural. It simply is going to be removes the E. Let's say if you want to do a raw call, say if you, 4Cs Morocco. It simply compares this word with the word online from online dictionaries and find the nearest. Sometimes yes, sometimes you might not gonna get it correctly because sometimes you got two words that are closer to the word that you are trying to check. Okay. Okay, so we have a sentence here. Yeah, let's create a sentence. Okay, so we create a sentence and it has some misspelling. So we got natural language misspelled, processing misspelled, deals with the art of extracting insights misspelled, from natural language misspelled. So we got a lot of misspelling in this one sentence. So we got a lot. So this is one misspelling, another one. The art extracting the insights. There's another one. Natural languages, another one. Okay, so now to correct this, so number one, we need to tokenize it. We need to spell it into words. And compare those words with the dictionaries and fix accordingly. So now we are going to tokenize this sentence. So we are going to override the existing sentence with a tokenized version. So we are going to print the sentence before and the sentence after. So we can compare them. Here we go. So this is the sentence before. Print the sentence. We got the spelling, and now we tokenize them. So we got the original sentence. We got the tokenized version of the original sentence, and now we are gonna go through. We are gonna loop through every single word that we have in the tokenized version of the original sentence, and we are going to apply the spell. The spell here is simply the speller in English, and the speller is a method that's been imported from autocorrect library. Okay, so we are going to do here, let's see. Okay, we are going to create a function, and that function takes one parameter and is going to loop through that one parameter and spells word by word or token by token and spell it, apply the speller, the English speller to it. And now we are going to print two things. We are going to print the original sentence, and we are going to print the corrected, or we are going to apply the sentence after we apply the correct spelling function with which simply correct the spelling of the sentence. So this is the original. It's token, and now this is the fix. So this word has been fixed. So we fixed all the spelling. This fixed. Now we got natural language being fixed. Processing ing. There's it's the right it's correct. With the art extracting insights, we got for the insights we got es, so it removes e. From natural language misspell, and we got the language. And we could do that for our paragraph. So let's copy the paragraph and see if it's going to work for us. So I'm going to copy this, and let's apply it to this paragraph. And of course we are gonna put some use some typos in it, and we are gonna see if it is gonna fix it. Okay. So let's do here Presidente Friday. Just add some typos in there to see. Nationals expected, meaty, order, trade, organizational. So we got a lot of typos in this paragraph. Okay, and we are gonna apply this function. Yeah. And we are gonna see if it's gonna correct our misspelling or the typos. Actually, we need what I'm doing here is we need to apply two parameters, two functions. The second, we need to apply the token. So we need to tokenize it first. Okay, so we tokenize the paragraph first, then we apply the spelling second. Here we go. So presidents. So it's still president with s is a correct word. So let's do here presidente, and so we got president. Here we go. Friday, Fridayo. Now we got Friday. Called on a national, nationals, national. Expected. So it corrected all our typos as far as I know. Okay, that is you could use this method, especially if there is a paragraph that has a lot of typos that you want to fix prior analyzing it. Of course, you don't want to have some typos and misspelling words in your analysis, in your text that you're trying to analyze. Okay, another things that you need to be aware of is we are going to see many this NLP is case sensitive, and it's simply what it is, it deals with words regardless of if they are uppercase, lowercase. Apple with uppercase is different than apple with lowercase, so we might need to lower all the cases. Number one. Number two, sometimes we have many words, they have the same I need to close this, sorry guys. So sometimes we have many words. They have the same root, but simply because it has an affix or a prefix, it's being treated differently. So we don't want to keep words with the same root and different spelling. So we are going to apply the stemming. Stemming is simply trying to find the stem or the root by removing the affixes. So there are many methods, and the one that we are going to use is called stem. And of course, I'm sorry, yeah, the one that we are going to use is called Porter stemmer. And there are other methods. There are other methods. There are Lancaster stemmer, WordNet, Poster stemmer, and WordNet lematizer. Yeah, there are three stemmer method, and the one we are going to use is Porter stemmer. You could use whatever you want. I think they are doing basically the same job. Okay, so we are going to import. Yeah, we are going to import the stem from the library NLTK, and we are going to create a function. We're always going to create functions because since we'll be reusing these snippets of code over and over. It's always good to automate them through creating functions. So you don't need to go through to create, to create a statement for every time you need it. Simply call the function, create a function that does statement for you, does spelling for you, correcting spelling, does tokenizing for you, and simply call the function whenever needed. It's better than this is one better way to automate a process. So we create a function called getStems, and it does take two parameters, the word and the stemmer. And the stemmer here is the method that you are going to use, and it returns a word. No, it returns a stemmed word. Stemmed word. So let's run it. Of course, this function is going to work, and now we need to determine the type of the stemmer we are going to use. In our case, we are going to use the Porter stemmer. Great. And now actually this is part of the function. Okay, so we are going to play with some words. This production. Yeah, let's say we are going to apply getStemmer, and we are going to apply it to production. So let's see what we are going to get. Product. This is IN. IN is simply an adds-on, an add. So it looks for the root. It looks for the root of the word. So if you have product, if you have in a sentence, you have a product, productions, and production. So they are going to be considered three distinct words, while actually they are one word but different spelling. So we want to eliminate, we want to find the words that they have the same root and group them accordingly. That is what this stemming is all about, is simply removing the prefix or affix and keep the word. So coming, if you run the coming, is going to come. It's going to it's going to simply the root of the coming is come. The root of firing is fire. The root of bottling is bottle. And of course there is a spelling. Okay, there's a misspelling in there, which sometimes you might need to lematize. Lematization is simply another method of stemming the word, but it goes beyond that stemming. It compares it with a dictionary. It's called a WordNet. It's an online dictionary. It compares the word. So if we were to apply limitize for word bottling, so we are going to get the BATTL, which is a misspell. Then it's going to compare it with the words in with the dictionary WordNet, and it's going to transform it into the nearest words using, of course, some distance measurement. It could be Euclidean distance. It's an algorithm. Okay, and so here we go. So we could use different stemmers. We could use the Porter stemmer. We could use Snowball stemmers, and there are other stemmers that you can use. So stemming, as the word suggests, is simply finding the stem of the word, or finding the root of the word, and keep it. So let's apply the stemming to the paragraph, to the tokenized paragraph. So always we need to tokenize. Let me see if we can apply that to our paragraph. So we are going to do get stems. So we have the paragraph, which is simply the paragraph that I copied from Yahoo. So we got this paragraph here, and the first thing we gotta do is we need to tokenize it. We need to split this into single words, and then we need to stem those words. Yeah, I think an extra stemmer, and I think yes, comma. List attributes. So let's do this. How about if I do there we go. So as I said, we have actually, let's use the corrected. Anyway, I'm not going to go through the misspells again because we did this. And now what it does, this stemmer, it looks for the root of the words, and it did not do it. So what if we were to use Presidente, for example? Yeah, president. How about awake? Is awake. Identification, it should be identify. Yeah, identify, and there is a misspell, and limmatization does a better job than stemming. Of course, both of them, they have pros and cons. Limmatization, what it does, it is going to stem, and it's going to compare it with the dictionary. It's very slow. Limmatization is very slow compared to the stemming, but it does a better job. So yeah, so sometimes the stemming process leads to incorrect result. This is an incorrect result, so we might need to compare the end result with a word dictionary, and fix accordingly. So we are gonna we are gonna download the dictionary from the NLTK, and we are gonna import the WordNet limitizer. So we are going to import two things from the NLTK, the dictionary and the method. And now we are going to initiate the method limitize. limitizer, which is going to be simply a method that we just imported. Then we are going to create another function. We are going to create another function, and all this function, what it does, it simply takes one parameter, one input, and applies the limitizer method to that one input. Okay, so this is the function get lemma, and now we are going to apply this get lemma on the product. So what it does, it takes the product and limitize it. Run the function first, and here we go. So it's very slow, as you see. It takes a moment, because what it does, after it finds the root of the word, it compares it with thousands of words on this WordNet and this dictionary we just downloaded, and it finds the nearest word from that dictionary to the word that we are trying to fix. Okay, if we were to do limitize for the word identification, then so let's compare the stemming with limitizing. So this is the stemming. We are going to compare the stemming with, of course, I'm a lazy person. I know, I'm very, very lazy. And simply, instead of typing, copy paste. Here we go. So yes, so for the stemming, it simply looks for the root of the word, identify. It does not care about the misspelling. Limitization, it does look for the root of the word, and it compares it to a dictionary. It corrects it. So for the stemming, it simply returns the root, which is identif, and for the stemming, for the limitization, it's simply compare it to a dictionary and fix accordingly. So that is the limitization. It has it's better than the stemming, but it's very slow, very slow. And if you have millions of words that you need to fix, of course, and if you did the math, guess, it's going to take a while to limitize all the words. And the stemmer is very fast, but you might end up having some words that are incorrectly incorrect result, or words that are incorrectly spelled. Another things that we want to learn today is named entity recognition. Is if we look into the sentence in our paragraph, can we identify the meaning, what these words symbolizes? So what is Washington? So it should be a location, should be a person, should be a day. So let's correct this first. So we are going to apply the spelling function one more time. So we are going to apply the correct spelling function one more time, because this has some typos. So we are going to override. So override the this paragraph. It has some misspelling with a corrected, but with another paragraph with the same paragraph, but apply the correct spelling function. Actually, we need to tokenize. No, I forgot to tokenize. So let me grab the tokenize method or tokenize function. Yeah, it's not working because we already override it. So I need to run this one more time. I need to run my paragraph one more time. Here we go. And now it is going to work. The reason why it's not working now because we already overrided the content of the paragraph. So now if I run it, we are going to see the actual the corrected our paragraph but corrected. Here we go. So yeah, and now we are going to use named entity recognition, which is simply a process of extracting important entities. So like person names, place names, organization. So we want to determine what these words that we have, or the most big words, the big words, what they symbolize. So NER is a method. Yeah, is a method. Named entity recognition is another NLTK process or another process that we can get from the NLTK. So we are going to import ni underscore chunk. This is the method we are going to use for the named entity recognition. Okay, and now we are gonna we already have a paragraph. We don't care about this. So the first thing that we need is we are going to create another function, and this function, what it does is simply takes one parameter. This function takes one parameter and it applies the anyChunk method. And before it applies the anyChunk method, number one, it tokenizes it. Number two, it applies some tagging into it. So it tokenizes that one parameter. So it takes one parameter, one input. It tokenizes it. It applies the pause tagging. Then it applies the NER or name entity recognition. So this is get NER. And we are going to get the function and apply it to paragraph. It's going to take the paragraph. It's going to take this sentence, this paragraph here. It's going to tokenize it. It's going to split it into tokens, into words, so we can navigate through, so we can loop through them. It's going to apply the pause tag that we saw earlier, and now it's going to apply the name entity recognition. So run the function, apply the function. So it simply looks for the most common words. It does not care about the other words. So it looks for Washington, and it should rename. It should find this Washington as a place, Joe Biden as a name. So we got here tree. What if we okay, let's replace this with our paragraph. For a reason it's not it's not doing a good job for a reason. Let's try it again. Okay, so it's going to take this sentence. So we have a sentence here. So it's going to tokenize it, it's going to tag it, and it's going to apply the name entity recognition. Okay, and now we are going to apply the function into the sentence. Still, all what you recognize is Washington. How about if we were to do let's say hold on. Yeah. So yes. So this is the tagging. Tagging. So as you see, it's tokenized. Number one, applies the tag, and it applies. This is the any is it's I believe it's I don't know what's its location. So how about if we say if we change this with something else? Let's do this. Let's say last year I went to Africa, let's say with my family. Okay, and let's see. So I'm expecting to identify Africa. Africa is an NA. How about to meet Susan, for example. Yeah, so we got Susan here is the name of a person. So Africa, it takes it as a name of a person. Okay, so another things that we could use for text analysis with NLP is finding the disambiguation. Sometimes a word can have many meanings. Like for example, keep your saving in a bank. It's so risky to drive over the banks of the road. So we got two words. Yeah, two words. They are similar words. Bank and the bank. As a human, we can definitely differentiate between the two words based on their context. But as a machine, it's very hard. It's really hard to do that. Hard has to be super smart to determine the difference between these two words. But the way it does it in NLP, it does take the consideration of words before and words after. So to determine the disambiguation, we are going to use a method called an algorithm called LISC algorithm. So it comes with NLTK. So it will so we are going to import the LISC algorithm from NLTK also, and of course we need to tokenize again. So that is very important. Tokenization is part of the process. So if you want to apply whatever process to your text, so you need to tokenize it first. So we are going to create two sentences. Sentence one, keep your savings in a bank. Sentence number two, it's so risky to drive over the banks of the road. So we got two sentences with one word in common. Okay, so so now we are going to apply we are going to create a function. Yeah, we are going to create a function, and the function, what it does, it takes two parameters or two inputs, and it applies the LISC. Yeah, LISC is is one method to solve the disambiguation by simply considering the context of the word. it looks for the context of the word in a sentence. So again, it applies the list algorithm on the inputs and it tokenize the input first, tokenize the input, and it applies the list algorithm. And now, so we have in these two sentences, we have the word bank, and we want to find if they are identical. So we are going to apply the get sign set or sign set. The get sign set is simply applying the list algorithm to determine the true meaning of the two of these common words of between these two sentences. So here we go. For sentence number one, it's a saving. It's different. It's a saving bank. It's a saving bank. If we apply this in sentence number two, it's a bank. It's different version. So a different meaning of the word. So even though we have two words, they are identical, but they are actually different. They have two different meanings. Okay, so that is one way sometimes you might need to use to solve your disambiguation. And of course, as I said, a word can be used and can have many meanings, depends on the context. So we need to determine the true meaning of a word by taking into the consideration the position of the word within a sentence, the words before, words after, or the context in general. So that's it. I think one last thing that we are going to do before I dismiss you is simply finding the sentence boundaries detection, or in other words, it's called sentence tokenization. So we learned about the word tokenization. Word tokenized method is simply split a paragraph or a sentence into words. And there is another method to split. If we were to split a paragraph into sentence, we are going to use the sent short for sentence for short, sent underscore tokenize method. So yeah, we are going to import from the sent tokenize from NLTK, and we are going to apply. We are going to create a function, and that function, it takes one parameter, which is going to be our input, is going to be our paragraph, and it split into sentence. So let's apply. We are going to create the function, and we are going to apply it on the paragraph. So we are going to apply it to our paragraph. So we are going to do get sentences and apply it into the apply it to the para, which is the paragraph that we created earlier. Okay, so let's take a look into the para again. Yeah, as you see, we have only one sentence. How about if we were to add some some apostrophes in there, some comma. So Washington D.C., Washington U.S. President Biden on Friday, comma, for example, full stop. I'm sorry, full stop. Called on nation expected to meet at the World Trade Organization, full stop. Okay, let's run this. So we got one sentence. We got another. Yeah, we got one sentence. We got another. And I know this is not a complete sentence, but just for the demonstration purpose, I decided to add a full stop with them to create some sentences. So the sent tokenize, what it does, it is going to split the paragraph into the sentences using the full stop. So now we are going to apply so we just created a function called getSentences, which takes one parameter, takes only one parameter. Of course, you can create a function that takes many parameters with no parameters at all. But for our case, we are gonna, it takes only one parameter, and that one parameter, we apply the send underscore tokenize, which is a method that we imported from the NLTK, and what it does is simply is gonna split the paragraph into sentences. So now you are gonna see more than a sentence. So this is the first sentence, and it's tokenized as you see here, comma, the second sentence, comma, the third one. Okay, folks, so what did we cover today? We talked about the pre-processing pipeline. We talked about tokenization and remove stop words, stemming, lemmatization, normalization, sentence tokenization, word tokenization. So I think you should be, if you practice the file that we shared with you, you should be able to master the pipeline. And for next week, then we are going to move into more advanced methods. So we are going to transform the ready to go or the corrected paragraph into, we're trying to extract some features. So we need to transform our paragraph into a matrix, into a tabular format, into rows and columns. So once we have the structured data, then of course we can apply any scientific methods, statistical methods, or machine learning later. So that's it for today, guys. Thank you for joining again, and I look forward to see you guys next week. Until then, you have a great weekend. For those who are in US, great vacation. And assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Bye, everybody.